Good evening, children. Today we are going to discuss soap and cleansing action of soap, formation of missiles. So now start with soap. What is soap? Immediately don't say that Santur, Lux, Synthol, etc. What is soap means what is soap by chemical composition. Soap is a sodium or potassium salt of long chain fatty acids. Soap is a sodium or potassium salt of long chain fatty acids. What is soap? Sodium or potassium salt of long chain fatty acid is called soap. Long chain fatty acids are carboxylic acids which are present in vegetable oils or animal fats. So for example, if I consider palmitic acid which is present in palm oil, having molecular formula C15H31COOH. Stearic acid which is present in coconut oil which is having molecular formula C17H35COOH. Oleic acid which is present in olive oil is having molecular formula C17H33COOH. These are present in vegetable oils, palm oil, coconut oil and olive oil. If you consider animal fats are containing still fattier carboxylic acids. That means what is soap? Sodium or potassium salt of long chain fatty acid. That means when these acids are made to react with alkalis like sodium hydroxide or potassium hydroxide, neutralization reaction takes place and resulting in the formation of sodium or potassium salt of long chain fatty acids. For example, if I consider reaction in between NaOH and C17H35COOH. C17H35COOH is stearic acid, NaOH is sodium hydroxide. So acid and base react with each other, participating in neutralization reaction, resulting in the formation of salt, that is C17H35COONA plus H2O. This is sodium stearate. This is nothing but soap. As a matter of fact, in India, most of the soaps contain chemically that sodium stearate. Sodium stearate is nothing but soap. Is that clear? So, soaps, if you want to go for the manufacture of soaps, you will be requiring vegetable oils or animal fats. Vegetable oils or animal fats are the starting material for the manufacture of soaps in industries. If you take coconut oil, that is containing stearic acid, olive oil, oleic acid, palm oil, palmitic acid. Actually, what are these oils or fats? Oils or fats are chemically similar substances. They can be defined as triesters of glycerol with fatty acids. Triesters of glycerol with fatty acids. What are oils or fats? Oil or fat is a triester of glycerol with fatty acids. Oil of fat is a triester of glycerol with fatty acid. You know that glycerol is nothing but propane 1, 2, 3 triol. What's glycerol? Propane 1, 2, 3 triol is known as glycerol. So from this I can get that oil of fat is triester. That means 3 ester groups are to be there. Of what? Glycerol with fatty acid. What is glycerol? Propane 1, 2, 3 triol. So now once again, what is soap? Sodium or potassium salt of long chain fatty acid is called soap. So palmitic acid C15H31COOH, stearic acid C17H35COOH, oleic acid C17H33COOH. So example of soap formation can be written as NaOH plus C17H35COOH gives rise to C17H35COONA, which is nothing but sodium stearate plus water. So major sources of these fatty acids are oils or fats. Oil and fat is chemically similar, which is nothing but a triester of glycerol with fatty acid. Glycerol is nothing but propane 1, 2, 3 triol. Let's have a look at the structure of oil. All those oils we don't discuss, just discuss the formula of coconut oil. That is tristearin, which is present in coconut oil. C17H35COO. C17H35 is R group. What is R group? Alkyl group. RCOO. That is nothing but COOR. That is ester functional group. How many esters are there here? This is one ester group. This is another ester group. This is another ester group. So how many ester groups are there? 3 esters. Triester of what? CH2OH, CHOH, CH2OH, which is nothing but CH2OH, CHOH, CH2OH. This is nothing but 1, 2, 3 propane, 1, 2, 3 triol. 3 alcohol groups are there. That is nothing but glycerol. That means triester of glycerol with fatty acids. Fatty, 17 carbon atoms are there in the chain, so it will be fatty. So triester of glycerol with fatty acid, that is nothing but oil. Actually, tristearin formula is this one that is present in coconut oil. Coconut oil is a major source, major starting material for manufacture of soaps in India. Okay, so coconut oil is containing stearic acid ester. What is this? Stearic acid ester. But what I require for the manufacture of soap? Stearic acid. That means ester is to be converted into acid. The process by which ester is converted into acid in soap manufacture is known as saponification reaction. What is saponification reaction? Saponification reaction is a reaction in which soap is produced. So that can be defined as saponification reaction is nothing but alkaline hydrolysis of oils or fats resulting in the formation of soap and glycerol. Alkaline hydrolysis of oils and fats resulting in the formation of soap and glycerol is known as saponification reaction. That means hydrolysis of oil of fat molecule in the presence of alkali leads to the formation of soap and glycerol. That reaction is referred to as saponification reaction. For example, coconut oil, when it is subjected to hydrolysis, that means made to chemically split by reacting with water, in presence of a base NaOH, it results in the formation of soap and glycerol. As soap is produced in this reaction, that reaction is referred to as saponification reaction. What do you mean by saponification reaction? Alkaline hydrolysis of oils and fats resulting in the formation of soap and glycerol is called saponification reaction. This reaction is quite contrasting to esterification reaction we have discussed yesterday. What do you mean by esterification reaction? The reaction in between ethanol and ethanoic acid in presence of concentrated sulfuric acid resulting in the formation of ester. There, carboxylic acid and alcohol are reacting with each other and leading to the formation of ester. But here what's happening is ester is made to decompose to produce soap and glycerol. So if I consider this soap obtained here, coconut oil is containing tristearin, formula I had given to you before. Tristearin, when it is made to react with water in presence of sodium hydroxide, it produces sodium stearate, which is having molecular formula C17H35COONA. If you see this is containing a carbon chain of length 17 carbon atoms and along with carboxylate group. Carbon chain C17H35 will be like this. That will be attached to COONA. If you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and COONA. It's better to write it like this than this. So if you see that soap molecule, this is CH3 group, intermediate groups will be CH2 groups. If you add all those, you will be getting this equivalent to C17H35. C17H35 part is a purely covalent part. That part is purely covalent. And if you consider COONA, this is an ionic part. Why? Because that COONA is made up of COO minus and Na plus. That means within the same molecule, two parts are existing. One is purely covalent part, that is long carbon chain, and another one is ionic part, which is carboxylate group. What is this group? This is carboxylate group. Okay, so now go for the discussion of cleansing action of soap. That means you all know that soaps are used for cleaning purpose. Soaps are used for cleaning our body, soaps are used for washing up of the clothes, soaps are used as shaving cream, soaps are used for washing your hair. So you may be getting a feeling that why this man is saying all these are soaps. All these are soaps. Shaving cream is a soap, shampoo is a soap, toilet cleaner is a soap. All these are soaps. Different types of soaps will be containing different substances. So why do you use this soap? It is used as a cleansing agent. So you'll be getting it. How soap can act as a cleaning agent. So what about the mechanism of cleansing action of soap? We're going to discuss it now. Cleansing action of soap. which is a very important 4-mark question as per your state board exams. Cleansing action of soap. Generally, that is used for removing dirt. Dirt is oily in nature. Dirt is oily in nature. Oils are purely covalent parts. Dirt is oily in nature. And for cleansing action of soap, I will be using soap along with water. Only soap can't go for the cleansing action. Soap is to be added with water. When soap is added to water, at low concentrations, that is giving rise to a true solution in which particle size is less than 1 nanometer. At lower concentration, soap forms a true solution with water in which particles are having size less than 1 nanometer. That means they can be seen with naked eye. But at higher concentration, soap will be forming a colloidal solution with water in which particle size ranges from 1 nanometer and extend up to 1000 nanometers. If soap is to be used as a cleaning agent, colloidal solution of soap with water can only act as cleaning agent, but not the solution of soap. Only the colloidal solution of soap can be used as a cleaning agent, but not the true solution. Why? Because in the colloidal solution of soap only micelles are formed. So once, let's brief what we had discussed until now. Cleansing action of soap. Soap is useful removing dirt which is oily in nature. Soap in water at lower concentrations give true solution in which particle size is less than 1 nanometer, that is 10 to the power of minus 9 meters. But at a concentration higher than critical micelle concentration. But at a concentration higher than critical micelle concentration, it forms a colloidal solution. In which particle size is in between 1 nanometer to 1000 nanometers, and these particles are called dispersed phase. What is that? Dispersed phase. So once soap is used for removing dirt which is oily in nature. Soap in water at lower concentrations give true solution in which particle size is less than 1 nanometer, but at a concentration higher than critical micelle concentration. That means concentration of soap solution in water above which a colloidal solution is found is referred to as critical missile concentration. It forms a colloidal solution in which particle size is in between 1 nanometer to 1000 nanometers, and these particles are called dispersed. This is very much important with respect to competitive exams like NTSC or Polycert. Particle size in colloidal solution is ranging in between 1 nanometer to 1000 nanometer. Particle size in true solution is of less than 1 nanometer. In colloidal solution, particles are referred to as dispersed pairs. The concentration of the soap solution at which a colloid is found is known as critical missile concentration. Now, I'm rubbing it. So let's go for the mechanism of cleansing action of soap. So that means for cleansing action of soap, you will be considering the colloidal solution of soap in which concentration of soap solution is greater than critical missile concentration. I said to you that in that colloidal solution, missile will be formed. You will be getting it out. What's a missile? Missile is a spherical aggregate of soap molecule. Spherical aggregate of soap molecule present in colloidal solution of soap. Present in colloidal solution of soap. So why soap molecules will be aggregated to form a sphere? You'll be getting it out. Why soap molecules will be aggregated to form a sphere? So now see, I said to you that soap is used along with water for cleansing action at concentration higher than critical missile concentration. I said to you that soap, consider C17H35COO-Na. Soap molecule is having two parts. One is carbon chain, which is purely covalent. Another one is carboxylic part. This is ionic in nature. One soap molecule is dissolved in water at concentrations higher than critical missile concentration. Soap missiles will be found as soap molecule containing two parts, which is carbon chain, which is purely covalent. This is hydrophobic, and that means that hates to be in contact with water. Hydrophobic, and you know that covalent substances are insoluble in water. So as it is purely covalent, you don't want to be in contact with water. This is ionic part is hydrophilic end. That means water loving end. This is ionic. You all know ionic substances are soluble in water, so it loves to be in contact with water. So in colloidal solution of soap, soap molecules covalent end, that is hydrophobic end, that is carbon chain, will be directed towards the dirt on the body or cloth, which is oily in nature, and that is also covalent in nature. Dirt will be directed to, hydrophobic end will be directed towards the dirt, and ionic end will be directed away from the dirt, that is towards the water. Like I'll be showing to you now, that one. If we assume this to be dirt that is targeted by soap molecules in such a way that hydrophobic covalent end, which is carbon chain, is trapping the dirt, and hydrophilic ionic end directed away from the dirt, like this, like this, like this. Soap molecules will be arranged around the dirt like this, leading to the formation of a spherical aggregate, which is nothing but missile. That is soap missile. That means soap, colloidal solution of soap, when it is used for cleaning dirt, dirt is entrapped by hydrophobic ends. All these are hydrophobic ends. These hydrophobic ends will be entrapping the dirt. Hydrophobic end is covalent, dirt is covalent. And between two covalent substances, there operate van der Waals forces of attraction. What are those forces? Van der Waals forces of attraction will be operating in between hydrophobic ends of soap molecules and dirt. These forces acting tries to pull out the dirt. But it can't. Why? Because van der Waals forces of attraction are weak forces of attraction. So in order to remove the dirt entrapped by hydrophobic ends of soap molecules, we have to agitate dirt thoroughly. Agitate means thorough shaking is required. Due to that force, dirt entrapped by hydrophobic ends will be taken out from the cloth or from the body, which is washed by water. So dirt will be immersed in water. Cloth is taken out cleanly. That's about the cleansing action of soap. Explain the cleansing action of soap. Soap molecule is made up of two parts. Long hydrocarbon chain, which is hydrophobic, and short ionic chain, which is hydrophilic in nature. When soap solution, colloidal solution of soap is used for cleansing action, soap molecules will be orienting around the dirt in which hydrophobic ends are targeted towards the dirt, which is oily in nature, and hydrophilic ends are directed away from the dirt towards the water, leading to the formation of spherical aggregate of soap molecules known as micelles. These dirt entrapped by hydrophobic ends can be taken out by thorough agitation. This is about the cleansing action of soap. Okay? Then what is micelle? Spherical aggregate of soap molecule. Spherical aggregate of soap molecule. And which micelles are present? In colloidal solution of soap. In colloidal solution, what will be the particle size? 1 nanometer to 1000 nanometer. What is soap? Sodium or potassium salt of long chain carboxylic acid. That's all with this lesson. Thank you.